Hey everyone. Sorry about the wait. No technical difficulty on my end. All right,
That
so yeah, sorry about that.
one question.
Go ahead, go ahead.
Was there class Tuesday?
No, no. I decided to cancel class. Like a whole bunch of things were going wrong. Like I couldn't log in. The building had a fire drill. The door was locked. I had to wait so long for public safety to get there just to open the door. So I just canceled class on Tuesday. But
Oh,
we will have classes upcoming Tuesday, so we'll see each other before Thanksgiving break.
okay. Thanks.
You're welcome. You're welcome. Yeah. All right, so let's pick up where we left off. At the end, we could do some questions if you guys have any like homework questions, but I figure everybody needed some time anyway to like really catch up on homework and stuff. So I hope you guys use that time to do that. Anywho, let's um let's start with a little blast from the past, all right? So I have this fraction right here. It's 30 divided by 48. And what I want to do, right, is I want to reduce the fraction, right? I want to reduce this fraction. Who remembers how to do this? Anybody? Anybody remember how to reduce a fraction? All right. Well, what we do, we look for a common factor for both, like let's say for both the top and the bottom, right? You don't have to pick the actual largest common factor that you can that is supposed to go into it. If it's if you see a smaller number first that goes into it, you could keep kind of hacking at it with smaller numbers until you can't do it anymore, right? So for example, I see the number 3, right? I feel like 3 goes into the top and 3 goes into the bottom a certain number of times, right? So for 30, I know that 3 times 10 is 30. And on the bottom for 48, I believe 3 times, let me think. 3 times 16, I believe, is the 48. Let me check. Might be wrong. Nope. That's it, right? So now 3 and 3 are common, so they can be canceled out like so. So now what do I have? I have 10 over 16. Looking at that, I could kind of see that, you know what, 2 could probably go into both of these, right? So 2 times 5 is 10, and 2 times 8 is 16. The 2's are common, so they can cancel out. So now, what am I left with? 5 over 8. And that's my final answer. Questions on this, anybody? Any questions on this? Everybody can hear me okay? Mic check.
Yeah, you sound good.
Awesome, awesome. All right. All right, let's take a look at another one, right? A little blast from the past. A little blast from the past. So I have this expression right here, right? It's our exponents. I have x squared times x to the fourth. Who remembers when I multiply exponents, what do I do to their powers? What operation? When I multiply exponents, what do I do to the powers? Anybody? All right, I add the powers, right? So this becomes x raised to the 2 plus 4 power. Let's call that x to the 6 power. And then that's it. Any questions on that? Okay, let's keep it moving. All right. This is another nice little blast from our past. So I want to multiply 7 plus 3x times 7 minus 3x, right? And you remember, whenever I'm doing this type of multiplication, I'm just going to FOIL it, right? So first, 7 times 7, 49. 1 second. Kind of freezing on my end a little bit. Okay, there we go. Sorry about that. I'm sorry, 1 second. I'm just like freezing a little bit on my end. Hmm. All right. So 7 times 7, 49. Let's see. Hopefully we're good now. Then we're going to have 7 times the negative 3x. I apologize. My computer seems to be freezing a little bit. All right. So 7 times the 3x is going to give me a negative 21x. Right. And then we're going to have the positive 3x times a 7, which is going to give me a positive 21x. And then we're going to have the 3x times the negative 3x, which is going to give me a negative 9x squared. It's going to give me a negative 9x squared. Okay. All right. So now what I want to do, combine like terms. You already know the middle is going to cancel out, right? So now all I have is 49 minus 9x squared. And there you go. That's my answer. Sorry about the delay. I'm writing, but it's just not picking up. It's like freezing a little bit on me. Okay. So that being said, let's get into what I want to get into today. We're just picking up where we left off. So I want to divide radical expressions. All right. So we have used the quotient property of radical expressions to simplify roots of fractions. We will need to use this property in reverse to simplify a fraction with radicals. So we give the quotient property of radical expressions again for easy reference. Remember, we assume all variables are greater than or equal to 0 so that no absolute value bars is needed or are needed, excuse me. All right. Let me give you guys the formula. There you go. This is the quotient property of radical expressions. If the nth root of a and the nth root of b are real numbers where b does not equal 0, and for any integer n greater than or equal to 2, then the nth root of a divided by b is equal to the nth root of a divided by the nth root of b, and the nth root of a over the nth root of b is equal to the nth root of a over b. All right? This is a really, 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 really useful, all right, property to have. It's going to help us a lot in the future when we're doing our problems. All right. So we will use the quotient property of radical expressions when the fraction we start with is the quotient of two radicals and neither radicand is a perfect power of the index. When we write the fraction in a single radical, we may find common factors in the numerator and the denominator. All right. Let's look at an example. Okay. Okay. So I'm going to look at A real quick. So I have square root 72, right? X cubed over square root 162x. Now I could do the square roots individually, the 72 x cubed over square root 162x, or I could write them under the same radical. Call that 72 x cubed over 162x, just like that. And then I could reduce the fraction on the inside and then take the radical, right? So let's take a look at that. Giant radical, right? So 72 divided by 162. My first instant is to just chop it in half. So half of 72 is going to be, I think, 36. And half of 162, I feel like is going to be 81. And then remember how we divide exponents, always the top minus the bottom. So x to the third minus x is going to give me just simply x to the second. You know what? I'm going to write the x to the second next to 36 right here. Just like that. And then now I have a perfect square in the numerator and the denominator, right? Let's look at those perfect squares. So the square root of 36x squared and the square root of 81. When we take the square roots, square root of 36x squared is going to be very simply just 6x over square root of 81 is 9. All right. Now we can reduce this a little bit. 3 goes into 9 3 times, 3 goes into 6 2 times. So call this 2x over 3 finally. Questions on this? Okay. Let's look at B. For B, I have the cube root, 32x squared, This is 4x to the fifth. Remember, I can write these under the same radical. So call that 32x squared over 4x to the fifth, right? And then we could kind of pull out greatest common factor here. So I'm going to factor out like a 4. Let me think. 4. Um, not 3. So I'm thinking about 8. X to the 4 over 4x to the fifth cube root. These two cancel out. So now I have cube root 8x to the 4 over x to the fifth. Divide them, top minus bottom. This is going to become 4 minus 5. Which is going to give me the cube root of 8x to the negative 1. Remember, it's illegal for me to have negative exponents, right? So this is just going to become cube root 8 over x, right? Now we cube root this, cube root of 8, cube root of x. We know that that's just plain 2 over the cube root of x. And remember, it's illegal for me to have radicals in my denominator, so we have to multiply it by the conjugate. So this is going to be times the cube root, right, of x squared. And what you do to one side, you do to the other. What we do to the bottom, you do to the top, excuse me, x squared. Final answer is going to be 2 cube root x squared divided by plain old x. Questions on this? Any questions? You guys try. You guys try. Welcome, welcome. Just trying out some problems. All right, let's take a look. Excuse me. All right, so for A, right? I want to write this under a single square root. So I have 50 s cubed over 128 s. All right, just like that. So now what I can do is I can reduce the fraction on the inside. Something that jumps out at me is 2, right? I know I can do 2 times 25, right? Good. Times s squared times s all over 128s, right? See if I give it a solid color, will it stop freezing? Okay. So now, actually, wait, on the bottom, I actually want to break that apart. Let me break that apart into 2 times, let's say 64s. And then now we're going to cross out our like terms. Boom. Get rid of the s's. There we go. And I'm left with 2 perfect squares, right? So I have square root 25 s squared all over 64. Oh, sorry about that. Okay. So now all we have to do is just do the square roots of each. Square root of the top, the 25s squared, over square root of the bottom, the 64. Call that 5s up top. Call that 8 on the bottom. That's it. And that's our final answer. Questions on this?
No, could you give me a second to copy it?
Sure. Take your time. Take your time. Take your time.
Okay, thanks.
You're welcome. No problem. All right, let's keep it moving. So the next thing that I want to get into, we're going to talk about rationalizing a one-term denominator. So before the calculator became a tool of everyday life, approximating the value of a fraction with the radical in the denominator was very cumbersome process, right? For this reason, a process called rationalizing the denominator was developed. A fraction with a radical in the denominator is converted to an equivalent fraction whose denominator is an integer. Square roots of numbers that are not perfect squares are irrational numbers. So when we rationalize the denominator, we write an equivalent fraction with a rational number in the denominator. This process is still used today and is useful in other areas of mathematics as well. Okay. Let me just give y'all a little definition real quick. Y'all know I like to repeat myself. For rationalizing the denominator. Rationalizing the denominator is the process of converting a fraction with a radical in the denominator to an equivalent fraction whose denominator is an integer. All right. All right. Even though we have calculators available, right, nearly everywhere, a fraction with a radical in the denominator still must be rationalized. It is not considered simplified if the denominator contains a radical. So similarly, a radical expression is not considered simplified if the radicand, right, contains a fraction. Okay. So long story short, what's the rule? No fractions in the denominator. Just a quick recap before we move on. So this is called simplified radical expressions. A radical expression is considered simplified if there are no factors in the radicand, have perfect powers of the index, no fraction in the radicand, and no radicals in the denominator of a fraction. That's it. To rationalize its denominator with a square root, right? We use, yep, with the square root, we use the property that the square root of a squared is if equals a, if we square an irrational square root, we get a rational number. Okay. Let's take a look. So we have a list of fractions here, but they have some kind of illegal activity going on with them. They have numbers in their denominator, right? So we can't have that, right? So what we want to do is rationalize that denominator. So I have 4 over the square root of 3, right? So I'm going to multiply this by square root 3 over square root 3. Multiplying straight across, we have 4 square root 3 over 3. That's it. Questions on this? All right, let's look at B. B is a little different. I'm gonna break this up. This becomes square root 3 over square root 4 times square root 5. Yep. And then the square root of 20 we know is going to be 2. Now it's illegal to have that square root 5 on the bottom, so I'm going to multiply this by square root 5 over square root 5. On top is going to give me square root 15. On the bottom, 2 times 5. So let's call this square root 115 and then call that 10. And that's it. Questions? All right. Oh, am I leaving one out? Sorry about that. How about C? So remember, it's illegal for me to have that radical in the denominator, but let me try and simplify this before I get rid of it. This is going to become square root 9 times square roots. Mm, 9 times 7. This becomes 3 over 3 square root 7. This is 1 over square root 7. All right. Again, illegal for me to have radicals in my denominator, so I'm going to multiply this by square root 7 over square root 7. Final answer, square root 7 over 7. Any questions, anybody? You guys try. All right, let's take a look. I'm looking at A. I have 5 over the square root of 3. I'm going to multiply this by square root of 3 over square root of 3 to get rid of the denominator. On the top, I'm going to have 5 square root 3 as my answer. And on the bottom, square root 3 times square root 3 is square root 9. And the square root of 9, we know that to be just simply 3. So 5 square root 3 over 3. And that's it. Questions on that? For B, I'm going to do the square root 3 over the square root 32. Let's simplify that. This is going to become square root 3 over square root 16 times 2. And we all know the square root of 16 is just square root 3. This is 4 square root 2. The 4 is okay in this problem, right? Well, my issue is that 2. So I'm going to multiply this by square root 2 over square root 2. And now I have square root 6 over 4 times 2. Let's call that 8. Square root 6 over 8. Questions on that? All right. Last but not least, let's look at C. This is 2 over the square root of 2x. And what am I going to do? I want to multiply this by the square root of, this should be 2x. And what I do to the bottom, I do to the top. So top is going to become 2 square root x. Bottom is going to become just plain old 2x. 2's will cancel. This becomes square root x over x. Questions on that? So the idea, you just multiply it by the opposite, get your critical value, look it up. All right. This is the real stuff right here we're about to get into. This is real right now. So what I want to do is I want to rationalize a two-term denominator, right? Oh, sorry. 1 second. 1 second. Okay. So we want to rationalize a two-term denominator. When the denominator of a fraction is a sum or difference with square roots, we use the product of conjugates pattern to rationalize the denominator. So a minus b times a plus b is equal to a squared minus b squared. And 2 minus square root 5 times 2 plus square root 5 is going to give you 4 minus the square root 5 squared. Call that 4 minus 5 or negative 1. So when we multiply a binomial that includes a square root by its conjugate, the product will have no square root. Okay. 1 second. All right, we good to go. So for example, I have 5 divided by 2 minus the square root of 3. What am I going to do? I'm going to multiply this by the conjugate. And what's the conjugate of this? It's the opposite of 2 minus square root 3. So it becomes 2 plus square root 3. But what I do to the bottom, I got to do to the top. And then you already know, distribute. So this is going to become 10, right? Plus 5 square root 3 On the denominator side, we're gonna distribute that, right? So for the denominator, why did that happen? This should be, let me write it out here. 2 minus square root 3 times 2 plus square root 3. Distributing that out, we're gonna have 10 plus 5 square root 3 over 2 times 2, 4, plus 2 square root 3 minus 2 square root 3, and then negatives and positives, negative square root 9. You already know how to do that. FOIL, boom, 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 boom. That's how we do that. So this becomes 10 plus 5 square root 3, right? Middles of this will cancel out over, what's this, 4 minus square root of 9 is just 3. So final answer, 10 plus 5 square root 3. Questions on that? Anybody? All right, if there's no questions, I'll let you guys try one. There you go, try that. Okay, let's take a look. So remember, I want to rationalize the denominator, which means get rid of the radical that's in the denominator. So what I'm going to do, I'm going to multiply this, right, by the conjugate. Conjugate means opposite. This is going to be 1 plus square root 5 and 1 plus square root 5. On the top, just distribute very simply. The top is going to be 3 plus 3 square root 5. And on the bottom, you're going to distribute. 1 times 1 is 1. 1 times square root 5, this is going to be plus square root 5. Negative square root 5 times 1 is going to be a negative square root 5. And then negative square root 5 times positive square root 5 is going to be a negative square root 25. Very simple, very simple, very simple. And then now let's combine like terms, simplify this. So this is going to be 3 plus 3 square root 5. On the bottom, we're going to have 1, right? And then we know the middle is going to cancel out. Minus and the square root of 25 we know is just 5, right? Let's combine like terms. We should get what? 3 plus 3 square root 5 over 1 minus 5 is going to be a negative 4, right? Now, I'll accept the answer like this. If you want to put the negative next to the division sign, be my guest. If you want to put the negative up top and distribute, whatever you want, right? Just make sure that you have an answer that looks something like this, and I would take that. Questions on that? Nope. Okay. Let's keep it moving. All right. We'll make this a little bit more complicated, but same process, same procedure, nothing to worry about. So take a look at this example right here. So I have square root 3 divided by square root of u minus the square root of 6, right? How am I going to answer this? The same way, the same process, right? Remember, I don't care about the radical in the numerator. I care about the radicals in the denominator. So I'm going to multiply this by the conjugate. So this is going to be square root u plus square root 6. That's the opposite. And on the top, square root u plus square root 6. And after that, everything is straightforward. Same way, we're going to distribute. So the top should be square root 3u plus square root 3 times 6, 18. All divided by square root u times square root u is just plain old u, right? And then we're going to have plus square root 6u minus square root 6u. And then negative times a negative, excuse me, a negative times a positive, excuse me, is a negative. And then square root 6 times square root 6 is square root 36. All right. And then after that, let's simplify as best we can. Numerator, we're going to have square root 3u plus, we could break this down. This could get broken down into square root 9 times square root 2, right? And then in the denominator, combining like terms, you already know positive square root u, negative square root u is going to get canceled out. We're going to have u minus square root of 36 is just what? 6. Simplify this a little bit further. I have square root 3u plus 3 square root 2 all over u minus 6. This right here is my final answer. Any questions on this? Did that make sense? Okay. Let me let you guys try one. But not too bad though, right? Same old, same old. We're just multiplying by the conjugate. And then we're getting rid of the radicals in the denominator, right? It's okay if the radical is going to be in the numerator, no problem. I just don't want the radicals in the denominator. Okay. I'll let you guys try that. Okay, let's take a look. Homework for this section has just been posted, everybody, so you guys can take a look after this. All right. So again, I have a problem with this question. There's radicals in my denominator. I want to get rid of them, right? So to get rid of the radicals in the denominator, I multiply it by the conjugate. The conjugate means opposite. So this becomes square root x minus square root 2. But what I do to the bottom, I got to do to the top. So this becomes square root x minus square root 2. After that, everything's straightforward. Distribute, distribute. This is going to become square root 5x minus square root 10 over, and do the same thing on the bottom, right? Square root x times square root x is just going to be x. Square root x times negative 2x is going to give me a minus square root 2x. Then we're going to have a positive square root 2 times square root x is going to give me a positive square root 2x. And last but not least, I'm going to have a positive square root 2 times a negative square root 2 is going to give me a negative square root 4. You know what? Let's just call it negative 2. All right. Let's combine like terms, all that good stuff. The bottom cancels out. Final answer, I'm going to have square root 5x minus square root 10 over the x minus 2. This is my final answer. Is there any questions on this? Any questions at all? Okay, let's keep it moving. I have another fun question for this section right here. This is going to be really, really, really cool. Check this out, check this out, check this out, check this out. So I have the square root of x plus the square root of 7 divided by the square root of x minus the square root of 7. Again, I don't care about the numerator, right? It's okay to have the radicals in the numerator. I can't have the radicals in the denominator. So I'm going to rationalize this by multiplying by the conjugate. What's this conjugate over here? Square root x plus square root 7. But what I do to the bottom, I got to do to the top. Square root x plus square root 7, right? After this, you already know what I'm going to do, right? We're going to FOIL this. Hold on one second. We're not listening. Sorry. All right, square root x plus square root 7. There we go. Okay, so we're going to FOIL this. Same thing. Square root x times square root x is going to give me just plain old x. X times square root 7 is going to be plus square root 7x plus square root 7x. And then square root 7 times square root 7 plus 7. All divided by square root x times square root x is just x. X times positive square root 7 is going to give me a positive square root 7x, and then minus square root 7x, and then a negative times a positive is a negative, and then there goes the 7. Let's combine like terms. You already know on the bottom. That's going to cancel out. Up top, we're going to have x plus 2 square root 7x plus 7. That's our numerator. All over the x minus 7. And that's it. That's my whole answer. Any questions on this? Anybody? All right. I'm gonna let you guys try one. Remember, I don't care about the numerator. It's okay to have the radicals in a numerator. It's a denominator that I want to get rid of the radicals from. So multiply by the conjugate, get your answer. I'm gonna give you guys a couple minutes. Try that out. All right, let's take a look. Again, I'm okay with the radicals in the numerator. I don't want them in the denominator. So what am I going to do? I'm going to multiply this by the conjugate. Conjugate is just the opposite of the denominator. So this is going to become square root p plus square root 2. What do I do to the bottom? What do I do to the top? This is going to become square root p plus square root 2. After that, just distribute, combine like terms, and then that's it. Square root p times square root p will give me just plain p. Square root p times square root 2 is going to give me a square root 2p. Square root 2 times square root p is going to give me a positive square root 2p. And last but not least, square root 2 times square root 2 is just going to give me a positive 2. Denominator, square root p times square root p is going to give me p. Square root p times positive square root 2 is going to give me a positive square root 2p. Negative square root 2 times positive square root p is going to give me a negative square root 2p. And last but not least, a negative times a positive is a negative, and square root 2 times square root 2 is 2. Let's combine like terms. The middle will cancel out. On the top, I will have p plus 2 square root 2p plus 2, divided by, it's very simply, p minus 2. That's it. That's our answer. Questions on this, anybody? No? All right, let's keep it moving. Let's keep it moving. I want to take it back to equations real quick. 1 second. No questions. Awesome. So I want to take it back to equations real quick. This is going to be real simple. Let me start off with a quick little blast from the past, and then we'll talk about how to solve radical equations, which is really awesome. So let's say I want to solve this. I have 2x minus 5 equals 0, right? And the goal here is I want to solve for x. So what does that mean? That means I want all my x's on one side, all my numbers on the other, right? So let's start this off. I'm going to add 5 over here, right? Because I want to isolate the x. That's the idea. Isolate x by itself. So I'm going to add 5 over here. But what I do to one side, I have to do to the other, right? So now I have 2x is equal to 5, right? Now I'm going to divide by 2 because I want to get x by itself. But what I do to one side, I got to do to the other. So now what's my answer? X is equal to 5 over 2. And that's it. Questions on that? All right. How about this? So we want to simplify y minus 3 squared, right? So remember how we did this? This is also the same thing as y minus 3 times y minus 3. And you distribute, combine like terms, all that good stuff. Or remember that we have that trick that we could use, right? Remember we have our perfect square trinomials, right? If I have a minus b squared, that's the same as a squared minus 2ab plus b squared. You can use that trick as well, right? I'm going to use that trick. So this should be what? Y squared minus 2 times y times 3 plus 3 squared. Put that all together. Y squared minus 6y plus 9. And there you go. All right. If that looks a little complicated using the trick, you know that it means y minus 3 times y minus 3. Distribute it, you can come back to the same answer. No problem. No problem. But what about the reverse? Let's say you had n squared minus 6n plus 8, right? Equals 0. Remember how we used to do this? We're going to factor this, right? I want two numbers that multiply to give me positive 8. And when I subtract or add them, excuse me, I get negative 6. That's going to be what? The n and the n. And it looks like we should have negative 4, negative 2. So negative 4 times negative 2 is positive 8. Negative 4 plus negative 2 is negative 6. Set both of these equal to 0. I have n minus 4 equals 0. I'm going to add 4 over here. What I do to one side, do to the other. So I have n is equal to 4. Last, I have n minus 2 equals 0. I'm going to add 2 over here. I do to one side, do to the other. So now I have n is equal to 2. And then boom, there goes our answers right there. Both of them, by the way. Questions on this? Anybody? All right, let's keep it moving. Let's keep it moving. Here's what we're getting into. So we want to solve radical equations, right? In this section, we will solve equations that have a variable in the radicand of the radical expression. An equation of this type is called a radical equation, all right? Okay. So radical equation is an equation in which a variable is in the radicand of the radical expression. It's called a radical equation. All right, got to build it up a little bit. Got to build it up a little bit. Okay. So as usual, when solving these equations, what we do to one side of the equation, we must do to the other side as well. Once we isolate the radical, our strategy will be to raise both sides of the equation to the power of the index. This will eliminate the radical. Solving radical equations containing an even index by raising both sides to the power of the index may introduce an algebraic solution that would not be a solution to the original radical equation. Again, this is called an extraneous solution. As we did when we solved rational equations, in this next example, we will see how to solve a radical equation. Our strategy is based on raising a radical with the index n to the nth power. This will eliminate the radical. So for a greater than or equal to 0, the nth root of a raised to the n power is equal to just a, right? Don't pay attention to that little typo right there. So basically, after you solve your answers, remember to check your answers, right? Remember to check your answers. Let's look at an example real quick. I'm going to look at an example. So here we go. So I want to solve the square root of 5n minus 4 minus 9 is equal to 0. So the first thing I want to do, let me isolate my variable, right? So I'm going to add 9 over here. But what I do to one side, I got to do to the other. So now I have square root 5n minus 4 is equal to 9. And then now I want to square this side to get rid of the radical. But what I do to one side, I must do to the other. So now I have 5n minus 4 is equal to 81. Then you're going to add 4 over here, which you do to one side, you do to the other. So now I have 5n is equal to 85. Then you want to divide by 5. And now what do we have? We have n is equal to, what's that? 1 and then 7, I believe. Let's see. 35, 25, 30, 35. Yep, that's it. Questions on this, please. Anybody? Okay, you guys try. All right, let's take a look. Again, I want to isolate my variable first, right? So I'm going to add 5 over here. But what I do to one side, I got to do to the other. So now I have square root 3m plus 2 is equal to 5. Now I want to get rid of that square root, so I'm going to square it to get rid of the square root. But what I do to one side, I must do to the other. So now I have 3m plus 2 is equal to 25. After that, I want to subtract 2. What I do to one side, I must do to the other. So now I have 3m is equal to 23, right? And then I want to divide by 3. What I do to one side, I must do to the other. So now I have m is equal to 23 over 3. Questions, anybody? All right. Let me give you guys a little procedure. Give you a little bit of procedure. So this is how to solve a radical equation with one radical. Step 1 is to isolate the radical on one side of the equation. Step 2 is to raise both sides of the equation to the power of the index. Step 3 is to solve the new equation. And step 4 is to check your answer in the original equation. All right. And that's how you solve these questions. So when we use a radical sign, it indicates the principal or positive root. If an equation has a radical with an even index equal to a negative number, that equation will have no solution. For example, for example, let's say that I have the square root of 9k minus 2 plus 1 is equal to 0. Same process, right? I'm going to subtract 1 and then I'm going to subtract 1, right? Because what I do to one side, I got to do to the other. Now, I'm telling you, once I get to this step, 9k minus 2 is equal to negative 1. Just the fact that it equals negative 1, I know that there is no solution. But just to prove it to you, let's work it out and see. So I'm going to square both sides. What I do to one side, I do to the other. So now this becomes what? 9k minus 2 is equal to positive 1. I'm going to add 2 over here, add 2 over here. So now I have 9k is equal to 3. Divide by 9, divide by 9. So now I have k is equal to 1 over 3, right? But now let's test it out. Let's see if when we plug this in, we get that same answer out. So I'm going to check it right here. So allegedly, right? If I have 9 times 1 over 3 minus 2 plus 1, that might equal 0. Let's see. This is going to become what? 9 divided by 3 is just 3. So 3 minus 1 plus 1, allegedly, that might equal 0. 3 minus 1 is called that square root of 2 plus 1. That might equal 0, but in fact, it does not equal 0. So therefore, this is not the right answer. And the right answer is no solution. That's that. Any questions on this? Anybody? Let me let you guys try one. Let me try that out. Let's take a look. So remember what my goal is here. I want to isolate my radical. So I'm going to subtract 5 from over here. When I do to one side, I must do to the other. Since I have a radical 2r minus 3, which is equal to -5, right? Think of it as soon as you see it equal to a negative, we can't justify it in the radicand, right? So the actual answer to this is no solution. But to prove it out, we're going to square both sides. It's equal to positive 25. I'm going to add 3. Then I'm going to have 2r is equal to, this is 5, 6, 7, 8, 38. Then you want to divide by 2, divide by 2. R is equal to 15, 16, 17, 18, 19. No, yeah, 19. Now, let's check it out. Check our solution. Allegedly, if I have 2 times 19 minus 3 plus 5, that will equal 0. Allegedly. So 38 minus 3 plus 5 should equal 0. So 35 plus 45, right? That should equal 0. But in fact, it does not equal 0. Therefore, this is actually not the right answer. The right answer is no solution. No solution. All right, let's keep it moving. All right, so if one side of an equation with the square root is a binomial, we use the product of binomial series pattern when we square it, right? So I just want to refresh your memories real quick, what I'm talking about there. So for binomial squares, if I have a plus b, it's going to become a squared plus 2ab plus b squared. If I have a minus b squared, this is going to become a squared minus 2ab plus b squared. Okay. Okay, binomial squares. So, same game as before, right? I want to isolate my radical. So I'm going to subtract 1 from over here. But what I do to one side, I must do to the other. Now I have square root p minus 1 is equal to p minus 1. What am I going to do? I'm going to square this to get rid of it. But what I do to one side, I do to the other. So now I have p minus 1 is equal to, I have p squared minus 2p plus 1, right? That's me using the formula on my head. Then I'm going to subtract p from here. What I do to one side, I do to the other. And then I'm going to add 1 here. And now what do I have? I have 0 is equal to p squared minus 3p plus 2. All right. And then you already know, I want to factor this. This is going to be P minus 2, P minus 1. And this will be P minus 2 equals 0. And P minus 1 equals 0. Let's solve for P. I'm going to add 2 over here. So I have P1 is equal to 2. I'm going to add 1 over here. P2 is equal to 1. All right. But I can't just take it at face value. I must try it out. So I have 2 and 1. So there goes my check. So I have 1 minus 1 plus 1 must equal 8. Okay. So, sorry. Will be equal to 1, right? So this whole thing you already know is 0. And 1 does in fact equal 1. So I know this is an answer. But it's 2 an answer. So I have square root 2 minus 1 plus 1 allegedly is going to be equal to 2. This becomes square root 1 plus 1, which might be 2. And in fact, 2 does equal 2. So that's actually an answer. Right? So moral of the story, you have an equation, you isolate the variable, right? The largest variable, and then you square both sides to get rid of it, and then you're good to go. You just solve for the variable in question, and that's it. Let you guys try one. So this is the same thing as before, right? I want to isolate my most complex, my largest radical, right? So I'm going to subtract 2 from here. If I do to one side, I do to the other. So now I have square root x minus 2 is equal to x minus 2. And then I want to square both sides. So I do to one side, I do to the other. So I have x minus 2 equals x um minus 2a b plus -2 squared. Okay. So now I have x minus 2 equals x minus 4x plus 2. I'm going to add 2 over here, subtract x over here. Combine like terms. 0 is equal to negative 4x plus 4. Subtract 4. Negative 4 is equal to negative 4x divided by negative 4. Right? So x is equal to positive 1. But again, don't take it at face value. Plug it in, see what happens, right? So I have 1 minus 2 equals, sorry, we have 1 minus 2 plus 2. So that should equal to 1. This becomes square root, what's that, 2i plus 2 does not equal 1. And in fact, this doesn't equal 1, so there's no solution here. No solution. Questions on this, anybody? Sec. Let's talk about something real quick. So the next thing that I want to do is I want to solve equations, radical equations with 2 radicals. If the radical equation has 2 radicals, we start by isolating one of them. It often works it often works out easiest to isolate the more complicated radical first. In the next example, one radical is isolated, the second is also isolated. 1 second. Sometimes, after raising both sides of an equation to a power, we will still have a variable inside a radical. When that happens, we repeat step 1 and 2 of our procedure. We isolate the radical and raise both sides of the equation to the power of the index again, and then we solve for it. Not too bad, right? For example, let's say I have this equation right here. All right. Let's say we have this equation right here. I want to solve for m. So what am I going to do? I already have my two radicals isolated. I'm going to square both sides. But you know what you do one side, you got to do to the other, all that good stuff. So now, what do I have? I have m, right? I'm just foiling this, plus 2 times square root m times 1 plus 1 is going to be equal to the square and square will cancel out, leaving back just m plus 9 equal to m plus 9. There we go. Let's put this all together. I'm going to have m plus 2m, excuse me, m plus 2 square root m plus 1 is equal to m plus 9. I want to isolate the radical, so I'm going to subtract m from here where I do to one side, I got to do to the other. I'm going to subtract 1 from here where I do to one side, do to the other. So now I have 2 square root m is equal to 9 minus 1. What's that? 8. After that, what do I want to do? I want to divide by 2, get m by itself. What I do to one side, do to the other. Last but not least, I have square root m is equal to 4. What am I going to do? I'm going to square this. When I do to one side, do to the other. So m is equal to 16. And it's that simple. After that, you have to test it out, check if it works. All right? Let's check it. I want to know if the square root of 16 plus 1 equals the square root of 16 plus 9. Square root of 16 we know is 4 plus 1. Does that equal this side, right? So that's what? That's going to be square root 25. And in fact, 5 does equal 5. So we're good. This is our answer. Is there any questions on that? Any at all? All right, real quick. Let me give you guys a little procedure, and then we could call it at that. You should be able to do your homework no problem after this, right? So this is our recipe, right? How to solve a radical equation when we have two radicals. Step 1, isolate one of the radical terms on one side of the equation. Step 2, raise both sides of the equation to the power of the index. Step 3, are there any more radicals? If yes, repeat step 1 and 2 again. If no, solve the new equation. And then, of course, step 4, check your answer in the original equation. All right, guys, that's it for today. All right. We'll pick this up on Tuesday. Everybody have a great day. I hope you all went to Pantry. Pantry was today. All right. Heard that they were giving out even extra turkeys in Roscoe Brown, believe it or not. All right. Everyone have a great weekend. See you on Tuesday. All right. Talk to y'all soon.